So surface area is the area of the surfaces. I mean, that's pretty straightforward. For a pyramid, however, in a prism, we had rectangles as our sides. In a pyramid, we have triangles in our side. So we are still going to use the perimeter. However, we're going to use different than height. So if you'll look at what they have going on here, there's a lot of information on this little page right here. You see that we have a vertex, which is normal. We have lateral edges and lateral faces, which we have had. Altitude, that is the distance from the peak perpendicular down to the bottom. And then we have this base. In this case, it's a square base. All right. Regular pyramid here. We have this new little height called the slant height. The slant height is the height of the triangle, right? So if you were to take the triangle and stand it up, that would be the height of the triangle, the slant height of your pyramid. And so that's really from the peak. It's perpendicular down based on the side. So you see this right angle, but it is different than the altitude of it. The altitude is at the peak and goes straight down the center. This goes down the side. And so when you're calculating lateral area, you're actually going to use this slant height because you're trying to find the area of the triangle. So you need the height of that triangle, and the height of that triangle is the slant height. So think if you took the triangle and just leaned it over, it's the height of that triangle. All right. And so they show you how this surface area and lateral area works. Once again, these add up to the perimeter of your base. So all of these bases of these triangles add up to the perimeter. We have the slant height of your triangle, or your pyramid here is the height of your triangle. And so if I'm trying to find the area of a triangle, what am I going to do? What's just the area of a triangle?
Base times height.
Base, 1/2 base times height. So I am going to take the base times the height times 1/2. So when we had perimeter times height to find our lateral area of a prism, we're going to do perimeter times height times 1/2, because now our sides are not rectangles. They are triangles, okay? And so if you look at the key concept here at the top of page 661, you'll see the lateral area here formula is 1/2 perimeter times slant height, okay? Slant height meaning the height going down the side of the pyramid, not the altitude. So this is your first formula here for this one is 1/2 perimeter times slant height, all right, times slant height. So let's look at example 1 in your books, middle of page 661, all right? The roof of a birdhouse is a regular hexagonal pyramid. The base of the pyramids had sides of 4 inches, and the slant height of the roof is 12 inches. If the roof is made of copper, find the amount of copper used for the roof. Hexagon, how many sides do I have in a hexagon? 6. So I'm going to say 6 times 4 is my perimeter. So 6 times 4 is my perimeter. My slant height, they told me that. What is my slant height? 12. All right. And then I'm going to take that and multiply by 1/2. So the lateral area of this is going to be 1/2 perimeter, which is 6 times 4, times 12. So I'm going to get 144 square inches of copper needed for this. So that is lateral area. Lateral area meaning just the area of the faces. And in this case, your faces are triangles. And then they want surface area. Well, what's different between a prism and a pyramid when you're talking about surface area? For a prism, we take the lateral area and what do we add? 2 bases, because we have a top and a bottom. What do we have with a pyramid? 1 base. And so if you look at the concept there, regular pyramid has a surface area, 1/2 perimeter times slant height. That's my lateral area. But now I'm only adding 1 base because my pyramids only have 1 base. So this is the second formula for pyramids. 1/2 perimeter times slant height. That's my lateral area. So once again, you're going to take your lateral area and you're going to only add the 1 base. The 1 base to your lateral area here. So let's look at the surface area of this pyramid. Find the surface area of the square pyramid. Perimeter we have, because they gave us 1 side, 18, right? So this is easy. If I'm taking perimeter, how many sides do I have? 4. That's good. So 18 times 4, that's my perimeter. They have given me 24 meters, but what is that? So the 24 represents the altitude. I don't need the altitude. I need the slant height. How must I find it? Pythagorean theorem. All right. So right here is halfway across that pyramid. So how long is that line right there?
9.
That is going to be 9. This they gave us is 24. What am I finding here? The hypotenuse. So I have a right triangle that has a base of 9, a height of 24. How do I find the slant height, which is what I really need for this? 9 squared, yep, plus 24 squared equals my slant height squared. So what is that?
25.
So you can put it all into your calculator at one time. The slant height is going to be the square root of 657. We need 1/2 times that. And then we also need to add this piece right here is just my lateral area, right? I still need to add a base. So how do I find the area of a square?
Base times height.
Yeah, so it's just the two sides, 18 times 18. Base times height. And so if I add all of that up, I should get 1,246.8. It is a big number. And it's meters squared, so that's a big pyramid. So in this case, we have a regular pyramid here. And we really need to find out more information. They've given us the slant height and they've given us the altitude. Slant height of 17, altitude of 15. And on top of that, our base is what? What is our base? Yeah, it's a pentagon, a regular pentagon. And so if I were to draw a line from where the altitude hits directly to where the slant height hits there, what line is that in a regular pentagon? What term is that? That is an apothem. So if I were to go straight from here to here, that is my apothem. Correct? All right? Which I need my apothem in order to find this particular pyramid. I have to have my apothem because I'm going to need to know some more information, which is the side length. All right? So the first thing I'm going to do here is I'm going to find my apothem with the Pythagorean theorem, same thing. Except now I have my hypotenuse and I have one leg. I'm searching for my other leg. So I'm going to say, well, 17 squared should equal 15 squared plus my apothem squared. All right? And when you do that, you should get an apothem length of 8. All right? When you solve that out, the apothem equals 8. And so now I have this regular pentagon here, all right, with an apothem of 8. I really need the perimeter. So what am I going to do to solve for this perimeter? I need the side length. Yeah, I'm going to set up a special right triangle, or I'm going to set up SOHCAHTOA or something to find what this particular one is. And I don't think you can use special right triangles for a pentagon, but if I do this, so I take 360 divided by what? Divided by 5. And then I take that and divide that by 2, right?
36.
So I get a 36 degrees right here. Is that what it is? Okay. 36 degrees. So in this case, I actually have to use SOHCAHTOA. I'm actually trying to find this guy right here. Based on this 36 degrees, and I'll make it a little bit bigger. Oh, I'm making it too big. Based on that 36 degrees, this side is opposite, right? And this side is adjacent. Which trig function deals with opposite and adjacent? Tangent. So the tangent of 36 should equal the opposite over my adjacent. All right, make sure you're in degrees when you do this because it's going to matter, all right? And then how do I find this side length here?
You're going to multiply 8 times the tangent.
Right, so I'm going to say 8 times the tangent, and I've actually only found half of the side length, right? Is that correct? So what do I need to do to this to find the whole side length? Multiply by 2. All right? So one side length then looks like a weird number, but we'll put it all in at the end. 16 tangent of 36. That's one side length, correct? Everybody agree with that? I mean, it's technically a number. We're just trying to not round. All right, so then how do I find perimeter? How many sides do I have? 5. So I have 5 sides. So if I were finding the lateral area, and they ask for surface area, so we have to find lateral area first. I'm going to say, well, lateral area is going to be 5 times 16 tangent of 36. That's my perimeter. And they gave me slant height. What is my slant height? 17. And I need to multiply that by 1/2, right? That's my lateral area. Everybody agree with that? All right, and then how do I find my surface area?
Add the base.
1 base. What's the base of a regular pentagon?
1/2.
1/2 apothem times what?
Perimeter.
Well, that's this big thing right here, right? So I'm going to write that again. 5, my apothem actually we already know, right? So we'll go ahead and write 8 there. 8. 5 times 16 tangent of 36. He's kind of getting crowded in there. All right? And so you're going to do the same concept with these that you would have if you were finding the area of a pentagon. You're going to have to pull back all the stuff you used with a pentagon, all right, and use it here. And then when you plug it all in, I think you get something like, what, 726.5. So you want to make sure that you can plug that into your calculator correctly and actually get something like this, all right? And I think they rounded throughout a little bit. So they rounded the side length, I think, to be 11.6. And then they rounded here. So if yours is a little bit off, they actually rounded this guy right here to be 11.6. So they would have put that in here. So if you put it all into your calculator, you may be a little bit off. If you round it, just show me in your rounding where you rounded it, like they did. So they actually showed that they rounded it. All right. Questions on that one? So number 4 is a square, which is going to give you a 45, 45, 90 triangle. They gave you the hypotenuse is 3 square root of 2. Your sides are the same length, 3 and 3, which is half of the side length, which is 6. So 1/2, 6 times 4, that's your perimeter. 3 square root of 2 is your slant height, plus 1 base, 6 times 4. The cone is identical, honestly, other than the lateral area. The surface area net actually looks like a Pac-Man to me. I don't know, for those of you that are Pac-Man fans, that's what he looks like when you lay him out. Honestly, it's the same concept. You have a slant height, you have a height of the cone itself, which is the altitude. And then, of course, your base is a circle. Based on what we just saw with pyramids, you actually get the same formula. So if I were to take the circumference then, because that is the perimeter of my base, how do I find circumference? What's circumference of a circle?
Diameter pi.
We're going to use with radius 2 pi r, right? And I multiplied that by my slant height. And what do I need to multiply that whole thing by since it's a cone, not a cylinder? By 1/2, right? Well, those 1/2 and that 2 cancels out. And so if you look at the top of the next page, you'll see the formula. Pi times r times L. The reason the 2 is not there is because you also have a 1/2. All right, and so your 2 and your 1/2 automatically cancel each other out. So lateral area of a cone is literally the same exact formula as the lateral area of a pyramid. It's just your base is now a circle, and so your 1/2 and your 2 cancel out. Diego has a conical lamp shade with an altitude of 6 inches and a diameter of 12 inches. Find the lateral area of the lampshade. So if my diameter here all the way across is 12 inches, what is my radius going to be? If I could see in there. Yeah, my radius then is going to be 6. They've given me the altitude. I actually need the slant height, right? And so I actually have this triangle that is created, right? And so if I have 6 here and I have 6 here, I actually have a special triangle, don't I?
Yeah.
This is actually going to also be a 45, 45, 90, right? So what is the slant height going to be?
6 squared to 2.
6 squared to 2. All right. And so I am going to do just pi times r, which we know is 6, times my slant height, which is 6 squared of 2, which gives me, when I round that out, 159.9. So it's just a matter of using either Pythagorean theorem, special right triangles, which if you use Pythagorean theorem, you'd get the same thing, to get what you need, and then just plug it in. It is identical to your pyramid. Pi times r times L. All right, then let's look at surface area. So if that is lateral area, what do you think I'm going to add to this to get surface area?
The base.
Yeah, which is what?
Pi r squared.
Pi r squared, a circle. And so if you look at the next formula, it is literally lateral area, pi times r times L, plus 1 circle, pi r squared. All right. So in this case, they want the surface area of the cone. That 13.6 is apparently the slant height. Again, they're not real clear here, but based on what they're doing here, that's the slant height. And so they've given me really everything that I need. My lateral area is going to be pi times r, which is 4.7, times slant height, which is, according to them, 13.6. And then I add to it 1 base, pi, times r, which we already know, squared. And plug it in, 270.2. And so these formulas are literally the same thing. Like, this is the same formula. It's just using a circle as your base instead of a square or, pentagon or whatever your base of your pyramid might be. All right, so let's try a couple of these. Some terms with the sphere, you have a great circle. That's a circle that runs through the exact center. So if you were cut a sphere at the great circle, you would have a hemisphere, exactly half of a sphere, right? Think of a basketball. All right. So basically you have just an infinite number of circles kind of that make up a sphere, and you have different pieces of it. You have this tangent line running to it. You have the diameter of it as well as the radius when we're talking about the great circle, the diameter of the great circle, the radius of the great circle. And so we have ways to find different portions of the circle. And the formula is actually pretty straightforward. The formula here is 4 pi r squared. If you were to lay it out, it would equal 4 exactly of the areas of one circle, of one of the great circles. And so that's your formula. Your last formula here for this particular chapter is 4 pi r squared. Find the surface area given the area of the great circle. What is the area formula for the great circle? What's the area formula of a circle?
Pi r squared.
Pi r squared. We know that pi r squared equals 201.1. What's the formula for my sphere? 4 pi r squared. So what do I need to do to that 201.1? To find this, yeah, multiply by 4. Multiply that by 4. If you have the great circle, multiply by 4. You have the surface area of the sphere. You'll notice there is no lateral area formula because there is only surface area. There's not a base to a sphere. What if they want the surface area of the hemisphere? Well, I'm going to take my 4 pi r squared, and I am going to cut that in half. So it's basically just 2 pi r squared, right? This isn't hard. My radius they gave me. So 2 pi times 4.2 squared, right? So I think the sphere is actually the easiest one. They will give you different things. They'll say, what if the radius is this? What if the diameter is here? Here's the circumference of the great circle, and you have to back into your radius. So kind of what we did when we learned circles, right? Where I said, find the radius given the circumference. They're going to do things like that, and then they're going to ask you to find the surface area based on, you really only need the radius. That's the only number you need to find the surface area of a sphere is the radius, all right?